So here's the solution. If you want to have a test like this, that looks like this, I mean, very maintainable, very scalable, simplify with all the best practices about Playwright. And then, do you know how to set up your Playwright system design folders to have a maintainable code? So here's an example. As you see here, we have components, data, features, services, stats, and utils inside the source folder. This is gonna be the recommended structure that I'm gonna be explaining in a minute. So components, where that comes. Do you know that in the front end development process they normally use components? Try to simplify the thing. Don't reinvent the wheel. Try to create the same stuff. This naming convention. Why to choose this? Because it's easy to read, easy to export, nothing too complicated. We had a common case and another kind of naming conventions. You can use that, but this is gonna be more readable in terms of how you implement these across the imports. If you see, this is more readable and connect model the component. So here is in my component folder, I'm gonna be having an index.tx, which is gonna be importing all and creating all the instances for all the sections folders that I'm gonna be having in the component folder specifically. So that's basically defined in this way, nothing weird. Just use the Playwright, conventions. Don't overcomplicate things. Just keep that simple and use the same stuff that the Playwright documentation has been providing for you. So that's my first advice about that. Data. Data is basically files in where you're gonna be having data. In this case, we had a CSV and JSON file specifically. Both are the same. Fixtures. Main stuff in Playwright. Simple thing. You can start implementing the fixtures just for not duplication of code, for having better maintainability, for having the approach you saw on the beginning of this video with the checkout status spec file. So this is my custom fixture specifically. I'm creating a new page here. I'm intercepting the loading of the page and blocking some specific things that I'm not gonna be needing for the test purposes. That probably is gonna be reducing the performance of the website by loading that stuff that is not needed. So this is the logic for intercept that and block the request. Then go to your best URL, wait for load state. This is because this website, the website that we are gonna be testing at the moment, is a little bit slow. It's having like a serious performance issues. And then this is the way we implement the rest of the things we had around it, like the services, like the utils. So if you notice, we have just services. The services basically is different files, types, present, API service. And the index is basically calling all the things like we have in utils. So because all the utils are basically generic functionality, general functions that you're going to be using as a service in all your test cases, try to have that in place. Just for having simplicity, readability, and maintainability of your code, one point where you have all the things you need as the utils. I'm using the same naming convention here just to have like a clear definition of what means each of them. In regards to constants, don't complicate the things. If you want to have all inside the object-oriented programming, try to use classes. They can be used for constants. It's not kind of different. Many people is spending setting up JSON files, setting up another kind of definition of constants specifically. But why? Here's one way to do it, and a simple way to keep that inside of the TypeScript classes. At the end, you will be using these color codes as a service in your code, where we can see that result and working. So let me go back here. Here we had an example service that word, country, US name. Same here, service, colors, hunted, that model. That will be simplifying your code and it will probably looking really good. No hard coding code, text here in the test block specifically. And then what else? This is very simple, nothing weird. Playwright config, couple projects, some stuff that needs to be configured, the reporting options, some timeouts, where it's gonna be my specs. Then the GitHub action setup, we had one workflow there. It's Playwright stuff that has been sending an email. I can show you that in a minute, so maybe we can go here. This is a GitHub actions setting up. I was testing some stuff around it, that's why it's failing. that the job is going to be looking like this. At the end, it's going to be sending an email if something fails. So let's go back to our code. Try to run the test case. It's gonna be taking time for sure, because this application is a little bit slow. I'm using one of the projects, which is Mobile Chrome specifically. Alright, it's moving. Hopefully it's gonna work. When this test case finishes, it's gonna be sending an email using Briceno API to my mail, and that will be one of the email senders functionality we had in there. Briceno API. We have another one that gives actions with this no mailer, which is a great thing as well. All right, let's go back to the code while we have the results. So here in service we have Briceno API. It's a way to send emails specifically. It's basically a class definition. So we're going to be sending emails after the test case finish in our after if hook specifically with the test info. That will be sending the test info or the execution at the moment. And saying here, we're basically this is the skip. We're skipping if the browser is WebKit and is a CI/CD. Well, that was really nice. It was finishing. All was good. Let's check the email. I think we need to receive an email. And that's true. Here's our email. That was sent with Briceno API. So, of course, in the user action, we're gonna having a different kind of email format. But this is a proof that you're gonna be sending email. You can connect your APIs. That means you have Jira, Trello, and other APIs open for your project management tool. You can report issues easily and quick with this